Hello, folks. How are you all doing? I hope you're having a really good Sunday or possibly Monday morning, depending on your time zone and your sleep schedule. So we're going to give this a couple of minutes for people to get notified, join, all that good stuff. We'll be having an available chat in two places. We'll be having it on Discord in our Git GitHub Bootcamp channel, and we'll also have the chat here on YouTube. If for some reason your YouTube is tied to like your real name, feel free to post in the Discord. We have that available for that reason. So, and by the way, I am Kat, your local events lead. I know, on video. It's a rare occurrence. Happens like twice a year. And in the call, we also have Mina via audio. So she'll be popping in, helping field questions, and making sure that I stay on track.
Yes, hello.
This is going to be probably more casual than like your typical workshop or boot camp. I intend to like make this really interactive and talkative. And like, if you're attending this and you're like knowledgeable in Git and you're like, oh man, Kat isn't right, speak up, correct me. I am by no means a Git expert. In fact, I don't use the command line. I will only use like visual editors. So if you are a bit more comfortable with Git than I am and you'd like to impart knowledge, like please feel free to pipe up in chat and share that. Like this is more of a collaboration workshop and boot camp than like a me lecturing to you. It's going to be much more interactive. And yes, this is recorded, so it'll be available later on our YouTube. In fact, you can even view last year's one. So you could even do that. And we'll also be repeating this workshop tomorrow at 12 p.m. Eastern. In case it's a little bit too late and you want to go to bed, you're welcome to join us in the timing that Mina posted in the server in 18 hours. See, Lemon Pie, the trick is to have two monitors and also two computers. I'm rocking 3 screens right now. And I can also do fun things like this from comments. We use StreamYard to help do some of like our YouTube live streams, and StreamYard's great. Highly recommend if you're like ever want to like stream a bunch. So Scofflaw asked, Git said I was in a headless state, so I rebased to an old branch and force pushed to origin main. How do I fix it? And the answer is, I have something for this. I need to find it. Here it is. You have one of my favorite articles. I'll also post it in this chat here. Does that work? Yes. Okay. It's an, oh no, I've made a Git mess, which is essentially a flow chart of like, how did you mess up? And then you follow the flow chart to be like, this is how I messed up. And it's like, all right, cool. This is how you fix it. It's great. Highly recommend keeping that like just stashed somewhere you can reference. I need to adjust my camera a bit because my camera blocks part of my tabs. Okay, we're good. Okay, we'll give it like 2 more minutes and then we can get started. Oh yeah, oh shit, Git. That's the other good one. Scofflaw posted in our Discord. I'll copy it over. This other good resource where it's like, oh no, I've made a mess. Because Git is powerful, and with great power comes great responsibility and a lot of potential to fuck up. It is almost easier to code with flowcharts until you have to have like threads, and then you stop doing that. If you've ever coded in, oh my gosh, I'm forgetting. Texas Instruments makes it. It's like little electrical circuits version of coding. I'm forgetting the name entirely, but you can like code in little like diagrams and loops. I liked what Lemon Pie posted in our Discord chat of save your code in an emergency, git commit, git push, leave building in case of fire. It's not Scratch. I need to find this now while we're like giving it a couple of minutes. Maybe it's not Texas Instruments. It's like, it's not MATLAB. It's not MathWorks. Oh, I might need to pull up my resume for this. Any electrical engineer knows what I'm talking about, or like any engineer that wanted to avoid coding, use this program instead. LabVIEW. It was LabVIEW. Thank you. I was going to lose my mind. It was LabVIEW. LabVIEW is a program I'm thinking of where you can like flow and diagram your code logic. At some point, it was a little bit too slow for how many instruments we were running at work. And so they asked me to thread it. And I'm like, can I just rewrite this in Python? And they said, yes, thank God. Yeah, it's like logic gates, but like on steroids. Okay, I think I've sufficiently procrastinated on getting this stream started. So we'll go ahead and get started. And I think this count is right, but hello to the 28 of you joining us. Very happy to have you here. I'm also glad there's only 28 of you. It makes this like less intimidating. So what we're going to be covering today is getting set up and started with Git and GitHub Bootcamp. And I said it correctly this year. So this is going to be a workshop and a bootcamp, ready to get you from you being like, what the hell is a Git? I thought that was Mr. Hemlock, to understanding enough about Git and GitHub so that you can feel comfortable enough like participating in the code jam, because our code jam does require you to use GitHub. So all that good stuff. So let's get it going. All right, so let's start off super basic. What is Git? So Git is what we call a version control system. Essentially what it says is it keeps track of changes in your code and who made them. And you get to control what we call a change. So the base of Git revolves around commits, which is snapshots of code. Every time you commit something, you are taking a snapshot of the code. And it stores that, and it'll keep storing snapshots so you can see how your code changes. And if you're like, oh no, that last change should not have happened, you can restore it to a previous commit, a previous snapshot. Your whole project and all of its commit history is what we call a repository, which we call for short repo. And finally, you can actually keep track of like simultaneous versions of different code with what we call branches. So you can be working on like the main code and your coworker's like, I have a different idea, but I don't want to slow you down. So while you keep developing on like the main branch, I'm just going to sort of take, it's like Doctor Strange of being like, well, we're going to explore this alternate like time reality for a bit. We're going to try this thing out. So they're doing changes simultaneously, but different changes. And eventually you're like, hey, actually this idea was really cool. Let's bring that back into main. And so then you remerge. We'll go through that later, but essentially Git lets you work simultaneously on different features and those features won't clash. So pretty good. And so where does Git run? Like, is it a program? Like, what is it? Well, it runs locally on your computer, and it is indeed a program. The way that it happens is that for each, Git will keep track of the folder that has a .git folder in it, and then everything below that folder. You can initialize it from the command line, and that's how it keeps track. It's like, oh, hey, there's a .git folder in here. That means I track this folder and everything underneath it. Don't put a .git folder under like users. I accidentally did that, and it tried to keep track of my whole computer and all of my programs. Work got mad at me for that when I asked IT to be like, so I accidentally committed my entire drive. How do I fix that? So that's how it works, is it looks for that folder, and if it finds it, it knows it wants to track everything beneath it. And finally, Git runs locally, but the whole point of it is that you can share it with others. So it allows you to interact with your repositories that's hosted somewhere else. So I have the repository on my computer, but Mina also has it on hers. And let's say we have some shared work computer that hosts it all. We can both push and pull through Git to this remote repository and then pull and like sync changes. So consider it like Google Docs. If you have offline mode, you'll keep making the changes. And then when you reconnect to the internet, it'll push and pull what's changed in the meantime. So that's sort of what Git does. Really, Google Docs like saw Git and they're like, cool. How do we incorporate that? Because that's really good. So Git runs locally, but you can also interact with things outside of your computer. And we do that usually through something like GitHub or GitLab or Bitbucket. And there's a couple of others. And Blue in our Discord chat says, thank you for the perfect explanation of why not everything needs to be tracked in Git. Correct. You don't need to track your entire users folder. All right, so first things first is while I go through this, if you're sort of like itching to do something while you listen, especially for my fellow ADHD folks, you can install Git while we get started. For Windows, you just download the installer, run through it. For Mac, you should use Homebrew. If you don't have Homebrew, step 0 is get Homebrew. And then for Linux, it depends what flavor of Linux you're running. You can ask the folks in Discord, and they will undoubtedly know what version of Linux you're using and what the command should be. I avoid Linux like the plague, so I am not the person to ask. So go ahead, install Git. That's the program that you want to run. For those on Windows, it's going to ask you if you want to install Git Bash, and the answer is yes. Git Bash is very useful to have. All right, so we just downloaded Git. Let's configure it. There's like 3 commands that you need to run when you first configure Git. It is, you set your name. You're like, cool, hey, this is my name. This is for each commit. It will be attached. Let's back up a little bit. Each time you commit, the way that Git keeps track of who made that change, it needs your name and it needs your email. That's how it's like, hey, who made this change? And then you do git blame. Then it goes to find the person responsible for that change. And 90% of the time, it's you. So if you git blame, it's 90% chance it's you that did the change. But the main thing is you want to put your name and your email. Like for instance, for me, it would be, give me 1 second, I need to open my other thing on my other screen because I don't remember these commands. So I would do git config global, and then user.name would be cat. And so if I do git config global. Is this how I do it? Never code live, folks. Never code live. It's always a mistake. Yeah, it's whatever. And then I can also do git config, and global means that it will apply to all repositories. For those that want to get a bit more advanced, you can actually set different like names and emails depending on which repository you're using. I know a lot of folks who have like a GitHub for work and then a GitHub for personal will use this feature a lot. For the code jam, global should be fine. And you can do user.email. And for this, like for instance, I can do like cat@pythondiscord.com, which no longer exists. This email no longer functions. But for instance, like that could be my email. For those that don't want to share your personal email, because for the code jam, you're going to put your email, and each time you commit, your email will be attached to that change, and it'll be pushed to GitHub. So people can see your email. If you don't want folks to see your personal email, then GitHub actually gives you like a GitHub commit email, which is an email that goes through GitHub servers that's used just for committing. So you can use that instead. I'll have a link for that. There's a link right there. What do you know? Yeah, you can use your GitHub email for commits if you'd like to keep your email not out in the public. All right, so we've installed Git, we've configured Git. So we're on our way to the races. The first thing is we have a brand new project. I should have made that bigger. No. It's okay. So the first thing that we do is like, hey, we have a brand new project we want to make. Let's make a new folder, and then we'll initialize the repository. So this is the command line version of doing this. I'm going to show you both the command line version of doing it and also using the GitHub desktop. If you are very, very new to GitHub and you're not comfortable on the command line, I really recommend you use GitHub desktop. It looks something like this. So you can clone a repository from the internet, which if you do that, you can just enter a URL and tell you where you want to save it, and you're good to go. You can also create a new repository like straight on your hard drive, or if you already have one that you would like GitHub to like recognize as a repository, you can add it. I really like using GitHub desktop. I'm more of a visual person, so command line and I don't really jive. And if you're visual like me, check out GitHub desktop. But otherwise, we will be going through both command line and the desktop. So let's do command line first. So the first thing is we will make a folder for our project, and we'll say, hey, Git, I want to start tracking this folder. So let's do that. So let's see what's in this folder right now. Okay, we're in documents, or let's go to documents. What's in here? Literally nothing. This is my streaming account where I don't have any of my personal stuff on it. So let's make my project. Cool, now we have my project. So let's go into it. So now we're going to do git init. Cool. Now we have a .git folder in here, which it won't show because it's hidden. But let me see if I can bring it up here. So it's a hidden item on Windows, but you can see that we do indeed have a .git folder. And so this is the folder where Git tracks everything. You can see it has like a file called head. It has hooks, objects, info, refs. Some of our more advanced Git users will like go into these folders and customize some things. For the code jam, don't worry about it. I would just leave this folder alone and not really fuck with it too much. And you can go ahead. For those who want to follow along with me, like while I create these repositories, like if you want to get comfortable with the commands, feel free. If you just want to sit and sort of soak it in and then do it later, that's also fine. We'll sort of have a little exercise for you later where you can sort of practice doing all of this. So you're welcome to follow along or just sit and listen. Both are fine. So cool. We're in my project and we have that. So the thing that you can do is Git status will tell you what it's tracking and what it isn't tracking. LSA, possibly. I'm not a command line expert. Let's try it. Nope, that is not the right command. No, it was. So not quite, at least not within PowerShell. But if I do git status, no commits yet, and there's nothing to commit. Nothing to commit means that Git is like, nothing's changed. I don't know what you want me to do about that. There's nothing. So cool, we at least have a repository. Git is like, hey, we're on the main branch. Hey, there aren't any commits, all that good stuff. All right, Git's tracking. So now we can make our first commit. For this, I am going to, I'm going to use VS Code just because that's what I'm most comfortable in, but you can follow along in whatever editor you would like. So I'm going to open the folder, documents, my project. Ta-da. Yes, I trust myself. Thank you. Thank you, VS Code. So I'm going to add a new file. And I'm going to call this a Python file. We're going to say print, and of course, hello world. And I do want to save this. Not quite. And I want to save this as main.py. Cool. So I now have my very first project. All of that is good. One thing here is that I'm going to keep going on the command line, but you don't really need to actually use the command line like at all. For instance, in VS Code, it has this built-in version control software integration. So if I go to this symbol here, that is it being like, hey, source control. This is how you do the version control. And it sensed that main.py has changed. So from here, I can press this little plus button, and it'll add it to what stage changes is. And we'll go through this in just a second. But stage change is essentially like, hey, I think this file with these changes right now is ready to be committed. So I wanna just get this ready to be committed. If I make any changes after this point, it'll actually be two different things. So for instance, I said print hello world, perfect. Maybe I want to add another statement. I can do something like print goodbye. No space there. And I want to save it. So all of a sudden, you'll see my file appear twice. Within VS Code, if I click this, you'll see that, hey, I'm ready to commit this. I'm ready to be like, this is the change I want. I wanted to put it to history. And then for changes, that's just things that have changed. I don't know if I'm ready for it. And you could be like, oh, hey, that's staged and this is new. Sometimes if you make all these changes and you're like, actually, never mind. I don't want to do this. For at least within VS Code, you can just be like, never mind, just discard those. I don't want to do that. And it just reverts to the original file. So pretty neat. I like VS Code. And also if you're like, oh, just kidding, I don't want to stage this, I totally misinterpreted a feature, you can just unstage it. So that's my normal workflow of VS Code, is I will use that to stage changes. I will write my little commit message up in here. The way that I'll do it is I'll do title, shift enter, description. And I'll write a good commit title, I write a description. I'll sometimes put little jokes in the description, all that good stuff. But that is my general flow. And that is how I record changes to Git. Within the command line, though, I need to remember these things. So I can let's do git status here. Okay, so we're on the main branch yet. There's no commits. Oh, but there is an untracked file, main.py. Cool. So it sees that it's changed, but Git isn't tracking it. It's not being recorded in history. This is entirely local to me. So what I can do is I can just do git add. I can either do dot. This will add all of the files that have changed. But if I don't want to add every single file, I can just specify, hey, I want to add this. I'm ready to sort of stage this. Cool. So now if I do git status, No commits yet, but I'm ready to commit main.py. So what you can do here is we can write our commit message. So we can do git commit, and it'll open up in this little editor. I use Notepad++ as sort of my default, like how do I work within, let me see if I can change, this is so tiny. Zoom in. I don't have a mouse on this laptop, so y'all are just gonna have to like bear with me. Just watch me slowly, just like a fucking boomer, slowly zoom in. There we go. So over here, I can write the commit message. All of these lines, like Python, if it starts with that hashtag or the pound symbol, it'll be ignored. So I can be like, hey, this is adding first file. That's going to be my title. I'm going to do 2 spaces just because that's how I like to do it. And I can be description. Yeah, description. And I'm just going to Control S this to save it. And then I'm going to close it. So one file changed. Let's do git status. On branch main, nothing to commit. My working tree is clean. Let's see, what does VS Code say? And VS Code says, yeah, nope, we're good. We're good. And this is what I also like to have the GitHub desktop for. Again, I'm visual. If I just see things, I'm just like, eh. So we're gonna add an existing repository. So the commit is what we just did, where we did like that git commit, and then it prompted the editor. That is what we did when we like committed to main. So if we go here, we're in my project. The current branch is main. Let's go to history. Ta-da! We can see the change right there, and you can see all of the changes on this branch, and you can see what I added. So I like using GitHub Desktop specifically for this feature of I can look at the history, and it provides really nice visual cues for what happened. So that is generally the workflow of adding commits. Right now, this is still all local though. Like no one besides me knows that these changes happened. And again, PyCharm has a similar integration for, we're going to open a project in PyCharm. Documents. Why does, oh, there it is, my project. Yep, just project. And for us, for me, the version control software, I've already configured this. Oh gosh, PyCharm, thanks. It just, yep. So up here, this might be called VCS for you. It might not be Git. I've already sort of configured what's happening here. But here you can sort of see, hey, I'd like to commit this, push, update project pull, show the Git log. Oh. It's working on it. PyCharm eats a lot of my resources, so that's why I usually don't do it. PyCharm's great if you have the resources for it. I think it's also indexing, but you can also do similar things in PyCharm. I'm just going to show it in VS Code for the time being, but we'll have like guides that you can follow for everything. PyCharm, please, I beg of you. Yep. Okay. So what actually happens when we git commit? And this is the part we're going to deviate a little bit from my PowerPoint. And I'm going to sort of show you how Git works internally. Because right now we've added changes, we know how to add changes, but like what does that mean, right? So the way that Git works is that it tracks things by these snapshots. So it's going to do things by these commits. So this little blue blob right here, is what I'm going to call commit number 1. That is the first commit. So what Git does is it's like, cool, that's the commit. And if people try to access it, I'm going to be like, hey, this is the current state of changes, right? Like this is what it is. Let's say I'm like, hey, just kidding. I'm going to make a couple of other changes. So I add a second file. Maybe instead of the hello world, I add the comma. I add hello, comma, world. And that is a new commit. I stage it again. So this is commit number 2. See, this is where Git is like, all right, cool. So that's no longer the most up-to-date. This is now the most up-to-date version. So when you see like the term head within Git or like a lot of software, they're talking about this arrow right here. I wish I could, hold on, I need like 5 colors. So they're talking about this arrow. That is what Git is pointing to as the most recent changes. It's like, hey, this is the most recent code. This is what you care about. Everything else, you can see the history leading up to this. So if people say that like, hey, I didn't want to commit this, I actually need to roll back. Usually what they're talking about is they want to move this little green arrow and they want to point it at a previous file. So they're like, just kidding. If people ask, this is really the true starting point and everything forward in history, ignore that. And if you like reset, that just means that you sever this link and you'll lose that history. So if you ever need to like do like git reset head hard, that means like you're just deleting the future. You're going back to the past and you're erasing the future. You're writing your own new future. Git will let you rewrite history. It's very powerful, but that's also how you get yourself in deep water. And /u gaming in YouTube chat. So a linked list. It's very similar to a linked list. I know for like my own mental model, that's sort of how I consider it. I consider it as like linked lists. So let's say that we do a couple of different commits. So when you add commits, all you're doing is you're adding more to this chain. So you're building on the history. So now you have like all of this history that you can now reference. And what happens here is, let's say that you are on commit 3, but your coworker is on commit 2. That's fine. Like it can handle those changes. And that way you can be like, hey, coworker, I just pushed my change to our shared location, and they can pull the change and their Git will be like, oh, there's more commits here. Let's keep going. So you can do some really cool things there. And you are, Mina says, you are required to hand draw your commit history every time you push.
Exactly
Sometimes
like this.
So when we do that, like git commit, that commit is us adding history. And you can like commit multiple files. You don't need to commit like one file at a time. You can even commit like parts of a file, which is pretty cool. One of our staff members, KJ, like enlightened us today in our planning channel, being like, this is a cool command. And it was like 5 of us going like, wait, that exists? I wish I knew that like 2 years ago. So there's a lot of powerful stuff you can do. So now we're going to talk about Git branches. So a branch is another really fundamental part of how to work with Git, especially within GitHub. So a branch is like a different version of your code base. It's like that Dr. Strange analogy of, hey, here's our main timeline, and we're going to call this the main branch. Occasionally, people will want to experiment with different alternate realities, right? Like that's how I like to consider it. So people will then spiral off of that. I'm going to use this little USB drive. So people will then sort of be like, hey, this is the same starting point, and now we're just going to change the history, and I want to go experiment. So we're going to draw this out again. Ta-da, we're returning. We have 3 commits. And let's say around about here, you're like, man, I have a really cool idea of what I want to change, but I'm not sure if it'll work. So I don't want to like necessarily like delay other people while I go figure this out. but it'd be cool if I can still like track history. So if it works, we can bring it back into like that main branch. This is what happens with Git branch. You're like, hey, Git, I want to make a branch. So what happens here is I'm going to change this a little bit. The green arrow is going to move to the top. So Git is like, hey, this is the main branch, right? So this is going to be main. And this is going to be like our test branch, right? We want to create this new test feature. So what we do here is we're like, okay, we're going to make a branch. And what happens is Git will now track which branch you're on. And that will have a different commit history than your main branch. So this is commit 4, but it has the same past. Oh, no, don't do that. Sorry, I'm drawing with my hand. So now we're on this branch and we're happily committing. We are figuring out how to write this feature. We're like, okay, we've got it. We're figuring out, we're writing good commit messages, adding a bunch of awesome features. And this is, of course, this is taking like days. And your coworkers or your teammates are still working on the main features. So you'll actually see here that they're still committing on the main branch. So you'll see that this is 4 here and 5. There's no meaning between me writing the number inside or outside the letter. I just can't make up my mind. And you're like, cool, cool, cool. So on the main branch, Git now thinks that the latest commit is here. But on your test branch, Git thinks this is the commit. So this is the history for the test branch. And this is the history for the main branch. They're different. So now when you're ready to merge in your feature and you're like, all right, like I'm ready to add it back into like the main release branch, there are 2 options here. But this is why you can do branches. If your coworkers are asking you to be like, hey, we need your help like fixing this old bug, you can keep everything on your feature branch the same. You can just leave it untouched. You can jump to that branch, help your coworkers and teammates. Doesn't affect anything you're working on. Git keeps it all in like this stasis. And then you can go back to your like actual feature branch when you're ready to go. It's really powerful for like keeping the code base like very separate and then combining it together neatly. Towards the end of this session, we'll experiment with creating branches on like my test repo, and you can sort of experiment creating branches, changing the branches, merging. You'll get time to actually do all of this stuff. Right now, I just want to make sure that you understand like what's happening under the hood, sort of. If you ask anyone who's actually good at Git, like if they start spouting that Git is a DAG, a directed something graph, they know more than me. So don't tell them I said these things. Directed acyclical graph. That is what Git is. So eventually, you will want to merge in your changes. We're going to get back on topic. You have 2 options. You have merging. I swear my handwriting is better than this. It's just Jamboard is not happening. And then you have rebasing. So what merging does is we're going to really go for the colors here. So rebasing is like, hey, you know these 3 changes? We're just going to move them to the end here. So if we rebase, then your history, when you rebase, will look like this. So you will have 1, 2, dot, dot, dot. No, I can do better than that. We're gonna do this the right way. So you have 1, 2, 3, 4, and this is all of like that original history. Nothing here is changing. And then that like feature branch, those like black commits, it's just going to stick them on the end and pretend they are brand new commits. It is essentially like taking those commits, severing this history. It's like, just kidding, you're not pointing here anymore. We're cutting that history off. And instead, it's going to just add it to the end here. This is helpful if your branch is very like feature independent. It didn't touch any of the other parts of the code that, for instance, these we're working with. Like, those were totally different features. You can then rebase, and it just acts like those 3 commits appeared out of thin air, and it just attaches it. So that's sort of what rebasing does. Merge commit will respect the history. And merging will be like, hey, this was the history, but now we're merging 2 branches. So we're going to add in what merging will do. Do this in red. Is it's going to add in what it's going to call a merge commit. That's just sort of like corrects any history discrepancy. Again, this isn't something that you really need to know like for the code jam, but it's good to have an idea on sort of the difference of merging and rebasing. There's also a really good article about the difference on them, which I'm going to share now because it explains it better than I can. I just wanted to make sure that like you at least were aware, because you're going to have that option in Git. It's going to be like, hey, do you want to like merge or do you want to rebase? You should at least know the difference. So this is the one that I like to reference for merging versus rebasing, because those are the 2 options of pulling branches together. And I will post it on the YouTube as well. So that's essentially what branches are. Branches is supposed to keep your code in different timelines so that they don't interact too much. You can code independently. You can switch what you're working on, and all your code stays intact. And it also allows you to cleanly pull it back together. And for working in teams, like branches is like the core of what you do. You commit things, you make branches, you commit things, you test it, you merge branches. And like that's what you do. You make a branch, you add your features, you verify it's good, and then you merge it into the main branch and just like rinse and repeat. That is how you work in a team using Git. So you want to get comfortable with committing things, and you want to get comfortable with understanding how branches work. And you want to make sure that you're comfortable with how GitHub does its merging. So those are the 2 things. GitHub, in my opinion, makes merging easier than doing it on the command line. So I recommend using the GitHub desktop for that. So that is how you do branches. And blue, before we get too far off to the next topic, merging has a downfall of it can handle like different histories. Like it can handle the fact that it knows it's a branch. So if you worked on like the same parts of the code and now you want to merge it back in and there's like merge conflicts, merging can handle that a bit more gracefully than rebasing. But your history won't necessarily be linear. Like you'll see a lot of like offshoots and recombines. There's a lot of like Git graphing tools you can use that will like visually show you how the commits go, which looks like my hand-drawn graphs, but like much, much better. All right, so there are different types of ways that you can actually approach creating branches. And this is coming from like a practical perspective of you're working with a group of people. It's your teammates for the code jam, or maybe it's your employers. And you're like, okay, how do we want to create branches? And there's 2 main types that at least I'm aware of. There might be others. But the first kind is trunks. Think of this like suitcases. If people generally work like independently, like, hey, Scofflaw, you work on this feature until it's done. Like that is your thing. And people will only work on that one thing until it's done. Like it's very sequential. I've seen that they tend to work in trunks. They will name a branch that will be like their name dash thing they're working on. No one else really interacts with the branch until it's like time to like review it. But that's generally how like the trunks work. I know one of my best friends, he prefers the trunk method because he doesn't like people to interact with his branches while he's working on things. So he's like, this is my branch, don't touch it. So that's sort of like the trunk method, the suitcase method. It's your stuff and you handle it until you're ready to like actually get it reviewed. And then there's feature branches. This one is more aligned with how Python Discord works with our repos, is that if you're doing a new feature, that feature is its own branch. For instance, on Sir Lancelot, we had the uwu command, which uwu-ifies your text. And one feature was to be like, hey, we need to make it like actually like reply to things. And let's say our other one was like, hey, we also want it to uwu-ify emojis. It's the same command, but they're different features. So each of those is its own branch. People can switch between branches to work on different features. If, for instance, I was working on this like uwu feature, and then I went on my honeymoon, because I got married, I could be like, hey, shenanigans, can you take this over? And they can just take over that branch and start committing to it instead. So that's how branches work, the branch is all about the feature and less about who's doing the work on the branch. And that's typically how Python Discord likes to work, because we're a bit more collaborative in that nature. And for the code jam, my personal recommendation is to work on feature branches, just because life comes up, like you're doing this for fun in your own time, that kind of thing. So I recommend feature branches. They're my preferred way to do this. The only thing is that if you have two people working on the same branch, push early, push often, and don't stop communicating. So those are the two different branching strategies you have. And now, finally, let's review what we've done. We've installed Git. We've configured Git. We even have our own local project that we're working on. It's time to actually like make this open source. We want to share our Hello World project with the GitHub universe. How does this come into Git? Like, what is the difference between Git and GitHub? So Git is the core of what actually does. Sorry, Chunky Dog, you made me laugh. Git more like mid, yeah. Git is actually responsible for tracking the changes. It handles the committing, it handles the merging, the branches, like it is in charge of the history. GitHub is simply a cloud that stores all of these different repositories. It is just this computer that everyone just can sort of like access and talk with, where they're like, hey, I want my friend all the way in California to see my repo. GitHub, can you hold this repository so they can also see it? That's what GitHub is. GitHub is just a big storage container of all of these repositories. But of course, GitHub is much more than that. It has additional features like pull requests. Pull requests are not a Git thing, it's a GitHub thing. But essentially, when you're asking to merge two branches together, GitHub is like, how about I make that process better? And it lets you review the changes through their UI online, and actually like see what the changes are. You can approve them. You can go line by line. You can go commit by commit, review the changes, request changes, like talk with your teammates. If you want to see this like really well done in action, like check out any of Python Discord's like open source repositories, go to pull requests, and you can see a lot of the conversations in action. So that's a GitHub thing. It's merging, but it also allows you, it gives you tools to like review the code better. So that is a really nice additional feature GitHub has added on top of merging. And then GitHub also has forking. So forking is, hey, I see that person's repository online. That's really cool. I want to build on it. So forking is making your own copy of it, but it's not directly connected to the original repository. It's like cloning the repository online, and then you work off the clone. So for instance, in Python Discord, if you're staff, you have two options. You can clone the repository directly, or you can fork it. The main difference is that if you clone the repository directly, which means that you're pointing straight to that Python Discord repo, if I make a branch and like push that branch in my changes, it will be reflected in that primary repository. However, if I fork it and then make those changes, those changes aren't reflected in the original repository. They're reflected in the repository attached to my GitHub account. So it's like cloning the cloud portion and then working from there. So it's a little bit different in like who sees the changes. It gets a little bit more complicated than that. The big thing is that for the code jam, don't fork. You are going to work directly off of your team leader's repository. If it asks you to fork, do not fork. That is the big thing for the code jam. In more open source culture, it is most people will ask you to fork if you're doing changes. They don't allow like commits or pull requests directly to their project. So it depends. But for this code jam, no forking. So now's the big thing is you have Git, you have GitHub. You know you want to put your GitHub stuff on, you want to put your Git stuff on GitHub. So there are two ways to do this. We're not going to quite go through this step by step like on stream, but we'll be hanging out in like our Discord channel, like helping folks set up their preferred method of connecting. So we'll be hanging around. We'll absolutely help you walk through like setting up SSH for the first time or figuring out how personal access tokens work. Just let us know, ask for help. We're happy to help. So there are two ways to connect your computer to GitHub's computers, because that's really what you want to do. You want to open a connection there, and then you want to say, hey, these are the files that I want to send to GitHub. So the most common is that if you're on Mac OS or Linux, or I think even like Windows 11, you want to use SSH, which is Secure Shell. I don't know the acronym. I thought I did. I don't. Anyway, it's
Shell is right.
Okay, secure shell. So it's like a little like tunnel. You're like, hey, you know my little command terminal? It's actually going to be like inside that command terminal. And the way that it verifies identity is with a key. So you have a public key and a private key. The private key, no one should know, not even your mother. Like you keep that shit secret. And then the public key will identify you to the world that like, hey, I am who I say I am. So what you generally do, and we will share these slides after, but you want to create your SSH key, which is your public and your private key. Some of you might already have a private key if you've like set up your SSH before, in which case you just need to generate a new public key. So let me copy this link. So you want to, and I like the Atlassian tutorials, like they're very good and to the point. And then once you create your new SSH key, then you want to add your SSH key like to GitHub. That way GitHub knows you are who you say you are. So create your SSH key and tell GitHub what your new public SSH key is. And that way when you try to push, it knows who you are. I was on Windows 10 when I first tried to set up like Git and GitHub, and it was not a good time. So instead, I used personal access tokens. Personal access tokens in this case is a GitHub specific thing. Something like GitLab has a very similar concept, but not every like cloud GitHub service has this feature. So it depends. A personal access token is essentially a password on steroids. You create it. It's authorized just for like a repository or like just for your user account. It's very narrowly scoped. You add it, you keep it in like a safe and secure place. Like for instance, I keep mine in my Bitwarden account, or you keep it in like the Git credential manager. And that way, when GitHub is like, hey, you're trying to push to this repository. Who are you? You can be like, hey, this is my username, and here is my personal access token, and it will grant you access to that repository. That would replace your password because Git no longer accepts passwords. It only accepts SSH or these personal access tokens, which are very limited in scope. So those are the two ways. For personal access tokens, it's as simple as creating it, saving it someplace safe, like the Git credential manager or like your password manager. It should not be saved as a text file on your desktop. I've seen coworkers do this. Don't do this. Don't do that. It's like leaking your Discord token. That should be secret. So that's how you do the personal access token. But those are the two ways that when you try to push to a repository and GitHub is like, who do you think you are? SSH or the personal access token will indeed, in fact, inform GitHub who you are and that you are authorized to make those changes. So That's how you connect those two. And both of them require telling GitHub, hey, this is who I am if I try to push. So in general, here's the flow for working with Git and GitHub. You've now done the authorization, you've connected it, like you're good to go. You can work with it via command line. Sometimes you have to if it gets like complicated, but mostly I use GitHub Desktop. For instance, I'm actually going to I don't remember what the repository is. Give me 1 second. I'm going to show you what it's like to like push and pull from the active repository. I need to like actually remember what I called it. All right, and that is so Git GitHub Bootcamp. So this is what you will do during the code jam. Your team leader will have this repository created for you. They'll be using one of our templates and they will create a repository that you can then clone. I like using the GitHub Desktop for all of this. So I'm in this repository and you can tell because current repository, Git GitHub Bootcamp, current branch main. You can even see that there are other branches that someone else has made. So you can switch to their branch and you can take a look. If I wanted to make a change to this, so let's open this in VS Code. We're going to open a folder. It's in GitHub. We're going to add a new file. We're going to do main.py and print hello world. We're going to save it. So this is my workflow if I just started the code jam, right? You clone the repository, you open it in your preferred editor. I make whatever change I want to make. I write a good commit. This is the title. Make it good. And then this describes in more detail what you did and why. So that is the commit title and the commit description. I am going to stage my changes because I always forget to do this. And I'm going to commit. Cool. Within VS Code, technically I can sync the changes automatically. I don't want to do that yet. I usually go here. So you can push or you can pull. Git push is when you are sending your changes to the cloud, right? Like you're pushing your changes up to the cloud. If you're doing pull, you're pulling down someone else's changes. You also have git fetch, but all you need to know for this is git pull. So over here, I'm going to go to repository, and I'm going to push my changes up to GitHub. Authentication did fail because I haven't actually set up my personal access token on this computer. But if you go through the setup with Git and GitHub, you'll be able to push and pull. For instance, if someone else tries to like push or pull right now, I would be able to pull down their changes, for instance. And you could also push and pull your changes. So you can see there that, hey, one file is different and can be pushed up to the cloud. So the core of what you do is you pull the changes down from the cloud. You make your own changes, you make your branch, you commit things, you write good commit messages, and then when you're ready, you push it back up. You can also push things in progress. So if you're stuck on something and you're like, hey, I need to go to work, can you just like take a look at this while I'm out? You push your branch, which is in progress, and they can also look at that branch later. Like for instance, I can go open this other person's branch and they have a different history and different changes. So I can see, oh, hey, like they're doing all of these different changes. They added .xml, modules.xml, so I can see all of their changes on their branch. So it's very handy for like, again, working with others. You can see others' branches, you can see their changes, you can see their history, and that is generally how you do it. Make a branch, commit your changes, push your changes, and then you pull down anything else that's changed. And also along with that is pull requests. But that is the core of how Git and GitHub works. It can get much more complicated than that, and people like to make it much more complicated than that. But honestly, like even just from working within like my work group or within Python Discord, I rarely need more than this. So you can do it via command line as well. So for that, I would look up the Git manual for the exact arguments, because you can like add aliases for like specific URLs for repos. You'll have like origin and like a lot of other terms. I just like doing it visually. And I recommend that if you're new to Git and GitHub, you just use it visually for a while and then like look at the command line stuff when you have the time. So there are some other really cool commands that we think are worth letting you know about. You don't have to know it for the code gem, but these are really powerful commands and they're really good commands. So Git rebase interactive. This lets you rewrite history with a fine-tooth comb. Like you can get your like smallest pen out and you're like, hey, you know that commit like 10 commits ago? I made a typo in the commit message and it's really bugging me. What if I just rewrite that commit but keep everything the same, right? Like what if I do that? Git rebase interactive lets you do that. Generally, if you do Git rebase interactive, it means you have to force push. You should only force push if no one else is depending on your branch. If other people have already reviewed it, if other people already have that history, don't do an interactive rebase. Just let the history be messy. Otherwise, you will have like pitchforks at your doorstep. But if you're on your own branch and you realize that like you messed up and no one else has touched it yet, rewrite history to your heart's content. Like go for it. There's a lot of different options, and I recommend like looking up guides for it. I always have a guide open next to me whenever I do an interactive rebase, just because there's so much you can do. And this one is courtesy of KJ. It is the git add -p and then your file or multiple files. This lets you stage parts of a file. So like you're writing a Discord bot and you have two commands. One command is ready to be added, but they're both in the same file. This git add -p will let you stage like part of the file. So that's pretty cool. I haven't used it, but it's pretty neat. Recommend it. So you can look that up in your own time if you really want to like dive deeper. Okay, so I see a question in the YouTube chat of what if I make changes locally and someone else pushes? So if the changes are conflicting, like say you had some sort of miscommunication, and now you and your teammate are both working on the exact same change, and they push first. If you try, you can pull it down, and it's going to be like, hey, this is not. There's conflicts here. Like the history is not vibing. You have competing histories. You're on the same branch, and you made a commit, and they made a commit. And those commits like don't jive. Like the history is not vibing. You will then get what is called a merge. I'm blanking.
Conflict.
Merge conflict. Thank you. I was like merge commit. That's not the right merge conflict. Thank you, Rita. And Git like has a whole thing for this. It's like whoa. The history is not good. You need to fix it, and it will let you choose. Like in an editor, you can just sort of like delete or add the code that you want, and then commit that new one. And that will be like a merge conflict commit where it's like, hey, we had some weird history going on. I have been designated as the one to choose what is the right one, and this is what we're going with. And after you do that, you immediately push that so that everyone else can pull it down. So merge commits is a special feature like within Git, and the GitHub desktop handles well, where it's like, whoa, history's not vibing. The commits, they are not going together. Fix this. I will not continue otherwise. And everyone say hello to my husband and my cat, Pixel. So, yep. I have two cats. One is sleeping in a corner, like behind that door. And this is Pixel, who has just been woken up from a nap. Say hello. She is not pleased. Thank you. Mm-hmm. Oh, she's going to my desk. Yeah. Okay. Like I said, this is going to be a casual stream. So that's what you do if like there's ever a conflict. Is for a special tool, you can go through all that kind of stuff. No, don't bring up the kazoo shenanigans. Do not bring it up. Okay, so you now know the core of how Git and GitHub works. We'll have some other guides where if we went a little bit too fast for you or I was a little bit too scatterbrained, we have other guides written by other people that are excellent that you could also follow before the Code Jam. But you should by now, hopefully, sort of understand how Git and GitHub fits together and how you can use it for the Code Jam. But there's some other cool features. So you have a GitHub pull request, which lets you, again, review code. Let me see if I can bring up what it looks like. GitHub.com/Python Discord/ let's go to Mr. Lancebot. I can't spell. Fantastic. I truly am the bastion of knowledge. Is there a space in Python Discord? So help me.
Hyphen.
Hyphen. Okay. I'm just going to blame the British for that for no particular reason. There we go. Oh, this is my other cat, Lemon, not named after the owner. They are both independently called Lemon. But he's also very cute, and he was sleeping and is disturbed. So, sharp. Sharp cat. So a pull request, usually when you do this, if you have a branch and you're like, hey, like this is ready to be merged, you've pushed the branch, you'll see like a little thing pop up there. Then it's like, hey, do you want to make a pull request from this? And you would be like, yes, I do. But you can also do like the new pull request button. There's a whole thing. But for instance, you can go to a pull request. And so you can write your little conversation here. It uses Markdown if you want to make it nice. You have people reviewing. For instance, here, Nugalore has already reviewed this. You can see comments made. You can see additional commits made. You can see like people are talking, interacting. They're making code better through reviews. If you want to review your teammate stuff, this is what a pull request sort of looks like here, where you can sort of see all the changes. You can see things were modified. It'll highlight the additions, the subtractions. It'll go through like multiple files. Like for instance, you can see the poetry lock changed. We don't need to review the poetry lock. No one ever needs to review the lock file, but it's still really cool that you can like see everything. With GitHub, you can actually like copy and paste screenshots and it'll automatically upload it to like their little like CDN network. So for instance, Shenanigans here did a great job of like, hey, this is what this thing will look like. It makes it way easier to review. Pretty great. So you have pull requests and reviewing. During the code jam, you can definitely use pull requests. It's good to know sort of like who has merged what's ready, how much you actually review, and like how you do the changes. That depends. I know when I participated in the code jam in 2020, we did like pull requests for like the first half, but then as we were running out of time, we just started merging main and just approving. We were like, we'll fix it later. It's fine. Just keep merging. Results may vary. Other features is you have forking. Again, went over this earlier, but for the code jam, you should not be forking your teammate's repository. Just work directly off of it. And finally, for those who may have like a team leader that's like super into GitHub and Git, and they're like, I do this for like my job. I am like senior developer at like Microsoft, if for that kind of thing. They may be using something called GitHub Actions. Actions is more of like a DevOps area. So it's GitHub's version of their continuous integration and continuous deployment. And for that, all that means is that like anytime a new GitHub event happens, and an event can be triggered through like a new pull request or a new issue, or maybe you have a new release, you can tell GitHub, hey, when one of these things happens, run this workflow. And that can be like automatically testing the code, automatically running like linting to make sure it abides by style guidelines. A lot of great stuff in Actions for the code jam. You shouldn't need to know this, but you might have a team leader who's like really into it. And if you have the opportunity to, take a look, learn some GitHub Actions. It's pretty powerful stuff. If you know GitHub Actions, your employer will definitely be impressed, or potential employer. Okay, and finally, what if I don't like the command line? I spent quite a bit of time not in the command line, but I want to shout out different tools. We have GitHub Desktop, which is free. Love GitHub Desktop. You have Git Kraken, which is free if you have the GitHub Student Pack. Git Kraken has some great tools for like visualizing like messy Git history. It's really good. I loved it when I had it as a student. And finally, you have VS Code with like Git integration, and you have PyCharm. I believe like Vim and Emacs also have their own like integrations. You can just ask in like editors and IDEs how to do that, because I'm like the opposite of like an Emacs user. Like we are different breeds of people. All right, and finally, again, I'll be posting these slides in like just a second, so you'll have all of these with all of the links. We have a couple of guides. If this workshop wasn't quite together enough for you, or you had to run halfway through or something, that's fine. There are other people who have done what we're doing, but like better. So we have Git and GitHub for Dummies. That'll get you like 0 to 100 ready for the code jam in terms of Git and GitHub. If you prefer video, there's also a pretty all right video crash course that Free Code Camp has done. If you want to just dive deep into Git and figure out like how it works under the hood in a really approachable way, we have Git is Magic from, I believe, a grad student at Stanford. We also have, oh no, I have a Git mess. Flowchart, you made a mess, follow the flowchart. And finally, we have a guide for how to write good commit messages. Good commit messages are both for future you and your teammates. Don't underestimate the power of being kind to future you. We have some interactive resources as well, like Oh My Git, which is a game to learn Git. Oh My Git, it's an open source Git learning game. So if you have some time and just want to like have some fun, like learning Git, there's even a game for it. I've heard it's pretty fun. You can also do learn Git branching. So if the branching didn't quite make sense to you, here's something much more visual that isn't hand-drawn by me, like on the fly, that really explains how branching works, and it's pretty good. We also have further reading, or if you want to really dive into the difference between merging and rebasing, we have that. And it has sort of like the workflow walk through the golden rule of rebasing, like when you should and should absolutely never rebase. And this is some pretty good illustrations here. We also have cheat sheets available for you. So if you just can't remember the commands for the life of you, GitHub Education has all of these like nice little cheat sheets that you can just sort of print and have next to you as you're coding. And finally, we are about an hour into this live stream. The Let's Practice is you can, from the, nope, none of this. From the repository that I posted about in terms of like, hey, you can practice live with their like repository and everything. You can just practice with that. If you want to figure out like, okay, I know I've seen Kat like practice how to make branches and make changes, but like it doesn't click until you do it. Now's your chance. I'm going to hang out for about another 15 minutes, but I'll be in chat for much longer as well. So if you have questions on like, hey, I'm having trouble setting up my SSH, or like, hey, I'm not really understanding how the branching thing works, feel free to ask and happy to answer. If you have any questions that I have not answered, now is the time to repost them so I see them, and I'll be happy to answer. So I'll be hanging out for another 15 minutes. Happy to answer questions. And let me share the actual slides. So these are the slides. They're on my personal GitHub. Eventually, they'll be transferred to the actual Python Discord one. They're made with Reveal.js, which is actually pretty swanky. Don't look at the commits. Just don't look at the history. And let me get that link for the how to write good commit messages. So I will share that here. and here. Sebastian also has, our owner, Sebastian, has a great sort of message pinned in our dev contrib channel that just really describes what a commit should be. Because there's this concept called atomic commits, where a commit should be as small as it can be that still completes a feature. So it's a very interesting concept of a pull request of, like, say you're adding a new feature, that should never just be one commit. That should be like 10 commits, because each commit should sort of be like the self-contained change. I think if you want to like look at really great like commit messages and like really great examples of like what a commit should entail in terms of like how many commits should go into a pull request, but like how big of a change is too big for a commit. And all of that. You can look at our bot repo and look for any PRs by Chris JL, Mark, or Sebastian, or Lemon. Those four are like, they do really well in terms of good practices for how to write commit messages and also how to write like how your commits should be staged. I have Captain Falloway in our Discord asking, how long can a commit message be? So for this, a commit message can be however long you want. The thing is let me make a change. Let me show you exactly what I mean. So the commit title should be about 90 characters. Your title should be succinct. Your description can be however long you want it to be, except each line should be about 80 characters and not much longer. The reason for that is that a lot of people will view like Git in the terminal. They'll do like Git log or like Git reference log. Nope, that's not it.
Git log.
Yeah. So you have Git log and also Git ref log. And that'll show you all of the different commits, and it'll also show you like the commit name and the commit description. Not every terminal does automatic character wrapping.
Sorry.
It's okay. Had a cat knock over my drink. There's hi Lemon. So let me show you what this can look like when I write a commit. So we're going to add the comma that Blue wanted oh so long ago. We're going to add the changes. And so I can be like, this is my Git commit title. It should be better than this. VS Code will tell me, it's like, you need to cool it. Like, this isn't an error. It'll still let me commit this, but it will warn me when I'm over the recommended amount. This is also why I like using VS Code, the Git integration, to make my commits. It'll tell me how long is too long. So let me say like, okay, I'll just do better title, right? Do as I do, do as I say, not as I do. And if I want to do a description, I can do, this is my description. It will be too long, and VS Code will yell at me eventually. There we go. It's like, hey, you really should keep this to like 72 characters. However, how many lines you have, you can do that for as long as you want. You can just keep having long lines and just making sure that you manually break them. There's some pretty good, like, really old, like, techie, like, IRC type posts, or really good, like, Git commits that you can, like, find out on the internet where it's just, like, paragraphs. My favorite is that a person was figuring out an error. The actual commit was a one character change. They needed to add like a dash in somewhere, or like one command line argument. But the commit message was like 2,000 characters because they were explaining like their entire, like debugging process, why this is the correct solution, how they figured it out, all of their process. So it's really helpful if you're doing something a bit non-standard, and you'd like to explain, like within the commit, hey, This is a little bit too long for the code, but here is why this is the way it is. It's really good if people looking be like, why was this change made? They can go to like git blame, which I think I can do from here. We're going to find out. Nope, I don't know commands. I just look at the GitHub UI, but someone else in the chat will know what git blame command to use. But it's really handy for like really documenting within the commit itself, like what's going on, and it might be too long for the code. And the reason you put it in the commit instead of the pull request is that if you pull the code down and you are now on a plane, you don't have access to the pull request. The pull request is independent of Git. So keeping it with the commit keeps it like really closely tied with the code itself. Because the PR is tied to GitHub, not Git, and the PR does not always follow the code. So that's the reason to put it within the commit message, not within the PR. It's if you don't necessarily always, your pull requests don't travel with the code. So that's why I like VS Code. Again, PyCharm has a similar thing, but my computer will die if I ask it to do things. So I'm going to not use PyCharm right now. And also, if you ever move off of GitHub, like for instance, your company was a small little startup working on GitHub, and now you are like multi-million-dollar, borderline Fortune 500, you're like, GitHub doesn't have what we want. We need GitLab. Not your pull requests and the info within the pull requests won't necessarily transfer over to GitLab. They might not, it depends. But the information within the commits, because it still uses Git, and Git is like its own independent little bubble. It's kind of related to GitHub and GitLab, but ultimately Git is self-contained. All of your information will still come with you wherever you go. If you like change like repo cloud providers, like switching from GitHub to GitLab. So that's the reason to keep the information as close to the code as you can. I usually put things in the PR, though. I don't actually put in the commit messages. If it gets too long, I get tired of typing. I like Markdown. But it's good to know for like future employment stuff. All right, any other questions, things like that? Yeah. And some fun fact before I will wrap this stream up, because I feel like 90 minutes is a long time to keep going. Git is not the one and only version source control provider. It's not the only option if you want to track like changes in your code. Git is actually relatively like the new kid on the block, but everyone really likes Git because of the way that they approached it. Another popular one that you will occasionally still see like hanging around is Tortoise SVN, so source version numbering. There's quite a few differences between like how these different version control like software like approached it. For most version control software, what they will do is they will track the changes, not the snapshots. So that's the big difference between like say Git and some of the other older version control options is Git will track whole code snapshots. It's going to be like, this is the full code right now. That's my commit. It's that whole code. If you ask Git for like, hey, what's the difference between these two? It will always recalculate that. It'll just calculate the difference. It doesn't know the difference between two commits ahead of time. It always has to calculate them. Of course, it'll cache it, but like, what also makes it powerful is if you have like 5 commits in a row and you just want to drop the middle 3 and you're like, hey, Git, what's the difference between number 1 and number 5? Git's like, I got you instantaneously. It's no different than it calculating the difference between commit 1 and commit 2. But if you were using a different version control like software program and all they tracked were the differences, they would need to know those middle commits to then piece together like what the actual code was. And that can make it messy if you need to like rewrite history. So that is one of the really powerful things about Git is its approach. Pretty great stuff. So Mina has asked someone to review her pull request. So if anyone has access to that repo or needs access, ping me in Discord and I'll add you to that repository. But you can practice doing like pull requests and everything else. In terms of what I use to write Markdown, I just use VS Code or Notion. Those are my two faves for writing Markdown. GitHub itself supports Markdown like within its little like pull request body, so I just write Markdown there. Yeah. Okay, otherwise, if there are no more pressing questions, I'm going to end the broadcast. We'll still hang out in the Discord channel for a while, answering questions. If you want help, let us know. I'll be around for at least another hour, helping with sort of how to do branches, make changes, do pull requests, do like merging or rebasing on the practice repository. And if you joined in the last like 10 minutes and you're like, fuck, I missed it, it's okay. This is recorded. You can watch it back later, or you can join us live tomorrow at 12 p.m. Eastern US time, and we'll be doing a repeat of this. So thank you all for attending. Hopefully this helped. Would love your feedback. We will make a feedback thread probably tomorrow that we will ping people in for some feedback about the boot camps. We want to make sure that this is productive for you. So if you think this could be structured better, or if you think some of the content was too detailed or not enough detail, we'd love to know those things. We want to make sure that this is workable for you and we're helping you be efficient learners. So feel free to give us some feedback in the chat now. Would love to have it. If you're interested in some of the more like advanced or intermediate Git features, like really diving into the command line arguments or like what an interactive rebase would look like, let us know. We have a bunch of folks on staff who would like love to just dive into like the nitty gritty things, all that kind of stuff. So feel free to give us feedback if you want like more detailed stuff, less beginner basics. We definitely have the staff knowledge. We'll be happy to get you more in-depth workshops. But thank you everyone for attending. No kazoo send-off, Keith. Husband has wandered off somewhere, probably walking on the treadmill. And I'll make sure that in the bootcamp Discord channel, we will pin all the information that we shared here, including the slides for you to reference as you mind. So good night, y'all, and thank you for attending.